Hey everyone, so today we're going to be going over something called Cramer's rule. This is where you use determinants to solve a system of equations. So first off, you need to know what a coefficient matrix is, and it's a very obvious definition. It's just a matrix that's consisting of the coefficients of the variables in a system of linear equations. So now we're going to solve a two-variable system with Cramer's rule. And in math, they're not very creative. It's invented by a Swiss mathematician, last name Cramer. So what he said is that if you're given a system, so you see that system there? Look at these coefficients. You create the coefficient matrix by just taking those numbers. Then you find a determinant. Remember, straight lines means determinant. As long as the determinant is not 0, then the system will have a solution given by, and then there's two formulas there. So there's a few things to look at. So when you find the determinant of the coefficient matrix, that's going to go at the bottom. But on the top, what you're going to do, let me put a different color, is you see these answers here, EF, you're going to substitute that column. So like, for example, if I wanted to find X, I substitute the X column with EF. And then BD still stays the same. And if I wanted to find Y, I would substitute the Y column with EF. So let's look at our first example. We have 2x plus 6y equals 38, and 5x plus y equals negative 3. So first off, what you want to do is make sure that everything is lined up. So the x's, the y's, and then the constants. But let's write our coefficient matrix. So we're just going to take the numbers from out front. 2, 6, 5, 1. And I want to find the determinant of that matrix. So instead of using brackets, I'm using straight lines. So determinant means that I'm going to get those diagonals. So I have 2, because 2 times 1 is 2, minus, now the other diagonal, 5 times 6 gives me 30. Which when I do that subtraction, I get negative 28. So that's the determinant that we're going to be using. Let me put this back on the screen, down here at the bottom. Okay, so now let's try to solve for x. Okay, so I'm going to write x here so we know what we're doing. We're going to take this 2 by 2 matrix that we made, and for this first column, so you see how these 2 and the 5 both went with the x's? We're going to replace that column with these numbers here, the 38 and the negative 3. So this time what we want to find is the determinant of this matrix. 38, negative 3, and then the other column, 6, 1, is going to stay the same. Okay, so determinant means we need to do our diagonals. 38 times 1 is still 38, minus negative 3 times 6 is negative 18, so I know this is going to turn to a plus sign. Okay, so that gets me 40, 56. Okay, but if you look at this formula, all we've done so far is we've done the top part. But now I need to divide it by the determinant of A. So I need to divide it by that negative 28 that we found earlier. And when you do that, you get negative 2. Okay, now let's go through and find Y. Okay, so we're going to look at our original coefficient matrix, but this time the first column is going to stay the same. The second column is what's going to get replaced with 38, negative 3. Okay, so now let's find our determinant. Our downward diagonal, So 2 times negative 3 is negative 6, minus our upward diagonal, 5 times 38. I'm not too sure. Let me grab my calculator. That gives me 190. So 6 minus 190 is negative 196. And again, we're not done quite yet. We need to divide by negative 28. And when we do that, we get 7. So now I officially have a value for x and a value for y. So I can officially write the solution to this system of equations as an ordered pair, negative 2, comma 7. That's the solution to that system. Okay, let's try another example of that. Okay, so this time, here's our system. 6x plus y equals negative 22. Negative 3x minus 2y equals 17. So our coefficient matrix is going to be 6, 1, negative 3, negative 2. Okay, let's find the determinant of that matrix. So we'll do our diagonals. That's negative 12 minus negative 3, so that's going to turn to a plus sign. That gives me negative 9. So we're going to use that negative 9 later on. But for now, let's try to solve for the other two variables. Okay, so if I wanted to solve for x, I'm going to get that square matrix that I came up with, and that first column, the one that had the x values, we're going to replace with negative 22 and 17. So first column, negative 22, 17, but the second column is going to stay the same, 1, negative 2. Okay, let's find a determinant of that. So our first diagonal would give me positive 44 minus our other diagonal, 17. So 44 minus 17, again, I'm going to use my calculator. I want to make sure I do this correctly. That gives me 27. Okay, but from before, the determinant of the original was negative 9. So we need to divide this by negative 9, which would give us negative 3. Okay, now let's do y. Okay, so this time, the first column is going to stay the same, 6, negative 3. But the y column, we're going to change it to negative 22, 17. So let's find the determinant by doing our diagonals. 6 times 17 is 102. Minus 3 times 22 is 66. So this gives us 36. But we still need to divide by negative 9, which gives me negative 4. So I have a value for x, I have a value for y, so I officially know the solution to this system is going to be negative 3, negative 4. So it takes a little getting used to, but it is a neat little pattern and it's pretty fast. And what I like about it as well is if you had a system where you don't need to find both of them, if they were to say that you only needed to find y, there's only one formula to follow. Okay, so these were 2 by 2s. Let's look at a system that has 3 variables. Okay, so with a 3 variable system of equations, Cramer's rule is exactly the same. It's just a little more complicated because there's more numbers to work with. So again, given a 3-variable system, and if you take a look, there's coefficients in front of each of those variables. That's what this is here. So as long as the determinant of this matrix here is not 0, then we can for sure find a unique solution given by. So that determinant would go at the bottom. You're always going to have to divide by that determinant. But on the top, you're going to find the determinant of the special matrix that you change. So this JKL, if you wanted to find X, you put it in the X column. If you wanted to find Y, you put it in the Y column. If you wanted to find Z, you put it in the Z column. So like I said, exactly the same as a 2x2. It's a little more work, but it still has the same pattern, so it shouldn't be too big of a problem. Okay, so I'll let you know right now, it does take kind of a long time to work all of this stuff out. So here on the page, I have 2 examples, but I'm not going to do both of them. I'm only going to do the first one. So we're only going to do that one example of a 3x3. Okay, so always make sure that everything is lined up. So X's, Y's, Z's, constants. Okay, let's write our coefficient matrix. So it'd be 3, -1, 1, 1, 2, -7, 5, -6, -2. Now we want to find the determinant of that matrix. So not as easy as the other ones before, where it's just the diagonals. We have to split this up a little. So hopefully you remember this from Wednesday. We start by taking the top left number and multiplying that by the determinant of this little square here. So that would be 3 times -4 minus 42. So I went ahead and I started taking the determinant. Then you would subtract the middle number times the determinant of this little 4x4. Now, this is -1, so minus a negative is going to make that turn to a positive. And because it's 1, it doesn't really make sense to write it. Let's just write the determinant. So that's -2 plus 35. It'd be minus negative, so I went ahead and put the plus. And then last but not least, plus the last number times the determinant of this little 2x2. -6 minus 10. Okay, so if I put all of this together, I get, this comes out to -121. Okay, so that was just the very first part. So looking at the formulas from up here, I at least know what I'm going to have to divide by every single time. So now let's start finding those variables. So let's start with X. If I wanted to find X, I'm going to look at this 3x3 matrix that we had come up with, but instead of these numbers in the X column, we're going to replace it with -23, 63, -14. So -23, 63, -14. But the other 2 columns are going to stay the same. So let me just rewrite those. Okay, so what we want to do is we want to find the determinant of this now. So same pattern. Start with the top number times the determinant of the bottom square. So that'll be -23 times -4 minus 42 minus middle number times the determinant of this little 4x4. Minus a negative will make that turn into a plus sign. And let's see, this would be -126 minus 98. Okay, and then last but not least, we add this number times the determinant of this little 4 by 4. I'm sorry, 2 by 2. So that would be 63 times 6. Ooh, I'm not sure about that. Let me use my calculator. $63 times 6. 378. Minus negative 28, so that'll be like adding. Okay, so let's put all of this together and see what we get. And this comes out to 484. Okay, but we're not exactly done yet. What we gotta do now is we need to divide by negative 121. And when you do that, you should get negative 4. Negative 4. There we go. Okay, so I know it seems like a lot of work, but we are still not done yet because all we've done is find the value of x. We need to go and find the value of y and z. Okay, so let's start with y now. So we're going to take the coefficient matrix and we're going to replace that middle column with these three numbers. Okay, so now that I have it written down, let's find the determinant of that matrix. So 3 times negative 126 minus 98, and then plus 23, negative 2 plus 35, plus 1, negative 14, minus 315. Okay, so now that I have all of that written down, let's find the total here. That would be negative 242. So we're not exactly done yet. We need to divide that by the determinant of the original coefficient matrix, which was negative 121. So this gives us positive 2. Okay, and then one last variable. We're almost done, promise guys. We need to go through and find z. Let's put it down over here. So we're going to take the original coefficient matrix and we're going to replace that last column with the answer numbers here. So it's going to turn into 315, negative 1, 2, negative 6, and negative 23, 63, negative 14. So let's find the determinant of that matrix. So we would have 3 times negative 28 plus 378 plus negative 14 minus 315 plus negative 23, but since it's plus negative, let's go ahead and just put minus. So minus 23, negative 6, minus 10. So now let's just find the total of this entire expression here. This would give me 1089 Okay, but we still need to divide that by the determinant of the original, which was negative 121. So when we do that, we get 9, or negative 9. Okay, so now I have values for all three variables, x, y, and z. So I can say with confidence my solution is negative 4, comma 2, comma negative 9. Okay, so like I said, a lot of work. It's not too difficult as long as you follow the patterns, but it is a lot of work. Okay, guys, and that's how you use Cramer's rule to solve systems of equations.